Hi, just a little preamble to this video. I actually shot this video a couple of weeks back and I was just about to release it as a world exclusive when Siglent said, hey, well, stop please, because we're going to change the marketing on this scope. Now, you'll hear me mention during this video that it's a 100 megahertz model scope and that it is $359. It's actually going to be $379 and it's going to be 200 megahertz only. So I am getting a new version of this scope, but this is the original one they sent me. I don't believe there's any difference at all between the 100 megahertz one I'm tearing down here and the 200 megahertz one that they're sending me. I believe this still has the 200 megahertz front end, and it was just being software limited as these companies do for marketing reasons. But Siglent have decided to go against that, and this is going to be an entry level 200 megahertz scope for $379 US with the free serial decoding and the 1 meg points FFT and everything we'll see inside this video. So I just wanted to clarify, if you see that further on or hear that further on in the video, it's changed. Anyway, on with the show. Hi, another world exclusive here. We've got the new Siglent ultra low entry level scope. It's the SDS1202X series, and you may have said, Dave, I've seen that before. You've had that on the blog a couple of years back. Yeah, I have, but this is the new -E model, not to be confused with the other Dash models they got available. This one is not actually released yet. It's been released in April-ish sometime, and the thing about this is that it's $359 US supposedly is going to be the retail price on this puppy. Now, the way it differs from the existing 1000X series, which they're still going to have, is that the 1000X series has options for a wave gen and a logic analyzer as well, mixed signal scope. This is not that. There's no option for a wave gen. There's no option for mixed signal scope. Don't even think about it. This is just your bare bones entry level 2-channel 100 megahertz bandwidth scope for $359, 1 gig sample per second. But this is actually a completely different design to the existing 1000X series inside, which we'll take a look at. It's super fast, super responsive, 1 meg points FFT, and one of the big selling features of this, and a lot of people have complained about this over the years, is that why companies charge for serial decoding. Well, this one has it built in for free. Beauty! As you can see, the front panel layout's practically identical to the existing 1000X series, except it has an extra button here for the wave gen, which this one doesn't have, but it's got the nice auto roll mode with the roll button in that. I've been using this in a debugging repair video I'm using at the moment, and I actually quite like that feature. It's working quite well, and it's got, you know, USB to save your waveforms, everything else, everything you typically expect in a bare bones 2-channel scope. And the inputs are a standard 1 meg, 18 puff, 400 volts peak, so reasonably high voltage inputs. On the back, yes, LAN is standard for the $359 scope, and we've got pass-fail and trig out and USB device as well. Your basic functionality, very nice for the price. Anyway, you know what we say here on the EEVblog, don't turn it on, take it apart. Interestingly, this one says nominal power 25 watts max. Most scopes of this sort of, you know, little small 4-channel scopes are normally, you know, like say normally 50 watts. So that's going to be interesting because there's some new circuitry inside here that's different to the original series. Can't remember what the original series was, but yeah, this one could be lower power. Now, I've done a video on how to remove these calibration seals without damaging them, so click up here somewhere if you want to see that, but screw that for today. Yoo-wee! As usual, we've got the 2 screws in the feet there, but curiously, we've got the screws vertically on the top this time and not in through like that. And by the way, if you want to see the previous teardown of the original 1000X series, click up here somewhere, this stupid new YouTube card thing, because they've turned off annotations. YouTube, like, you can't, they've just completely abandoned annotations now. So I can't, like, annotate videos and, oh, don't get me started. They reckon cards replace it. Bullshit, they do. Unbelievable. I can't leave a regular text comment in a card, but I can link to video. So tear down for this up there somewhere. Anyway, let's open it up. Whoa, here we go. Let's see what our built down to price scope is like. I still can't remember. I should go watch my video for the other one. But that's interesting. Usually we have a two, you know, the power supply separate, then comes off. This one, it looks like the top, it's just slightly different to how they normally are. Anyway, let's crack it open. Lift this up. There was only 2 screws on here, all Phillips, by the way, different to the regular Torx you find. And bingo, we're in like Flynn, no separate shielding on the power supply. They've completely separated that. Single board construction down the bottom. We'll have a look at that. But that's, you know, interesting. This is supposed to have a 500 microvolt front end, but of course it's all shielded, so, you know, no worries. They're probably, you know, not hugely concerned. There's nothing inherently wrong with that. It looks like quite neat and tidy, actually. I do like the look of the power supply. They've put a little cable tie on there with the earth strap and the main ribbon power supply ribbon cable here. So that's interesting. I have to cut that to move it out of the way to get the photos. And look, they've put Loctite on the connector. Nice touch. They've done that over here with the fan, and they've gone to the effort to route the wire under there, under the main screw there, so it's not flapping around in the breeze. Nice attention to detail. I like it. And in terms of airflow here, we've got the air blowing out this side here, and it's sucking the air from over this side. There are vents here, but they aren't in the top or bottom. So that's blowing over the power supply and over the heatsink fins as well. They're even correctly oriented like that to get the maximum airflow over them. Nice. Power supply is certainly neat and tidy. It's got all the business. Nice fully encased fuse there. We've got isolation slots absolutely everywhere. Look at primary and secondary here with the opto couplers. Very nice. There's our main switching transformer. We've got requisite MOV protection and a common mode choke on the input. The earth lead is your standard fare. That seems tight enough, so that's a neat looking power supply. They've elastic all the caps down. Lelon caps, yeah. Not exactly Panasonic's. And you might not be able to see it, but they have gone for Lelons pretty much everywhere else as well. They look like the Gold Series ones. They're probably low ESR jobs, so yeah, at least they're stuck with the one manufacturer. But you know, this is a bottom of the range, scraping the barrel, $350 odd retail scope, so that's a pass. At least it's neat and tidy. Now, unfortunately, to get the main board out, it looks like I've got to do, well, 4 self-tapping screws into the top metalwork here. So this top metalwork lifts off because there's no nuts on the front, of course, for the BNC. They're on the metal on the inside. But to get to the last nut, I got to take the power supply off. Grrr. And I think they got a bit of elephant hide on the bottom there. Elephant hide on the bottom. They're just insulating that. The backside of the board for those playing along at home. Look at that, nice touch. High voltage isolation slots between each pin of the bridge rectifier. Neat. Okay, so all this is supposed to pop out. No, got to undo the ribbon cables first. Oh, ourselves a nice big juicy ferrite right across the main LCD ribbon cable there. Could that be a last minute, you know, EMI oopsie perhaps? Tell you what, I really like the fact that you can just swing out the power supply like this and get in there for the board. Of course, no touch. You don't accidentally scrape the bottom of the board down here. But yeah, nice access for hacking. Speaking of which, check this out. Look, easy access right on the edge of the board and labeled the not only the JTAG interface, but for all the world like a UART. Look at that. Just like beautifully laid out, and there's even an extra pin header over there. I don't know what that is, but yeah, like purpose designed, readily accessible for hacking. Go for your life. And I forgot to mention, there's no sign of any of the trademark Siglent rust on the chassis, on the edges of the chassis. So yeah, they've upped their game. And here we go. Let's have a squiz inside. Got this under the Tegano microscope. It's all on one board, as you can see. Now, this is very interesting because the heart of this is the Xilinx Zinc processor. They've completely changed architecture on this thing. That's what's under the heatsink. Sorry, that's glued down. I won't be taking this off. It's the only one in the country, so I don't want to ruin it. So I don't know exactly which Xilinx Zinc model it actually is. Anyway, it's the Zinc processor. That's all you need to know, which we've seen before in the GW Instec 1000B series, and that's what gave it its incredible bang per buck performance in terms of FFT, processing the 1 meg point FFT, which is what this Siglent one has as well. And of course, the beautiful thing about the Zinc processor is that it contains not only a Xilinx FPGA in there, a reasonably capable one, but also an ARM, I think it's a dual core ARM processor in there. So, you know, tightly knit coupling between the FPGA and the internal ARM processor, and hooked up to DDR3 memory, I believe it uses. I haven't actually looked up those numbers, but you can if you're playing along at home. They should be DDR3. You can see all the length matching there, all the classic length matching stuff. They got the little wiggle, 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 yeah, to make them all identical length, because you got to length match those puppies. Otherwise, you get timing problems at such speed like this. Now, the previous 1000X series from Siglent, we've seen the teardown. I'll link it in down below. It's actually got it ran on the Blackfin DSP platform. So they've completely changed the platform that this thing runs from. Although I'm sure, you know, a lot of the code is compatible and everything else. They probably was able to port that over relatively easily. But yeah, they've got it all on one board. And the interesting thing is that it is on the main board, whereas we saw it on a daughter board, just the processor part on a daughter board inside the GW Instec, and that was to lower the cost, because you need to fan out this BGA, you need a big multi-pin multi-layer board. You know, there's all the bypass caps and everything else. They've fanned out almost every via on the thing by the looks of it, and to get that out you need like an 8-layer board or something, like minimum, to get that out. And we've also seen that motherboard approach in the, or the daughter board approach in the new Keysight 1000X series as well. Once again, to get the cost down, keep all that multi-layer complexity on a smaller board. But hey, for this ultra low-end one, it's different. So I'm very surprised to see it integrated into the main PCB. But the PCB itself is relatively small, so maybe that's why they can get away with it, and they can fit multiple ones in the one panel, of course. Yep, you can see the mouse bites. There you go. You can see the mouse bites there and there on the board, which shows it's all panelized, so you could probably fit you know, they've size optimized this probably to fit 4 of these, like on one PCB panel or something like that. So that's how they can get the cost down. Otherwise, the bare board alone, if it's 8 or 10 layers, just because you need this part to be high density, because most of the, you know, the rest of it can be 4 layers, no problems whatsoever, and you'll get away with that fine and dandy. But all this stuff is, you know, probably 8 layer just to fan out the pain in the butt BGA package Zinc processor. But that's the price you pay. But it's interesting that they haven't gone for the daughter board approach. So I'd say, because this board is pretty darn small in the scheme of, you know, complete motherboard, complete oscilloscope motherboard type boards, you know, they've done well. So they, you know, that would have been a real cost optimization exercise anyway. That looks like a lead, is it? What? HL? HL? I don't think I've ever seen a HL designator before, but that looks like, I mean, it's got a series resistor in there, so okay. Or is it some sort of ambient light sensor? I don't think so. It's probably just a LED, like a heartbeat LED or something like that. Anyway, what is all this big array of transistors around here for? What? It's got 2 test points associated with it. Seems to be hooked into the Zinc processor up there, but like, why? What are they doing? I don't know. That is very curious. Anyway, JTAG interface, no worries. Whack our 0.1-inch header on there. So what do we got there? Just a 7404. Got ourselves a crystal there. BOFPC. Thanks for telling us all the information on that one. Not. Just a 244. Some Jelly Bean logic. And the ADF 4360. And if we're going on over the data sheet, that's our PLL, basically our VCO, our voltage controlled oscillator. That's what generates the main clock there. So yeah, it's Jelly Bean 1. I think we've seen that before. And but it's all about, of course, the loop components that you actually put inside this thing. And I'm sure if you scroll down far enough, you'd find examples of various loop components, which some companies, who shall remain nameless, Rigol, have screwed up the loop on the and with all the built-in registers and everything else. Anyway, there's the loop filters for those who want to analyze that to see if they're goofed up. Go for it. And moving on from that, what do we got here? We're entering our trigger section of the board. ADCMP, I think that's just a comparator, and 74HC4053, got to have some 4000 series CMOS in there, no wuckers. Sells a classic 595 again, 74HC4051, oh, it's all happening, all Jelly Bean stuff. Anyway, this is the trigger section, some local regulation across there, analog VCC's got its own separate 5 volts, and nice little test points all labelled, and that's the interface. But people wanted to see the ADC. We almost missed it. There it is. It's a HAD 1511. Let's check it out. And here it is. It's a 1 gig sample AD converter, so no, we're not going to be able to overclock this thing anytime soon. And we've probably seen this in other parts as well. Typical applications, digital oscilloscopes, thank you very much. So yeah, it's purpose designed for this sort of thing. And of course, it's got the 4-channel interface in there. And of course, the 1 gig samples per second will halve, of course, because it's not 1 gig sample per second per ADC. It's 1 gig sample per second total. So when you turn on that second one, it's just going to halve, and well, I'll link it in down below for those who want to check it out. Oh, all right, calm down. I know you want to see the analog front end. Well, here it is, 2 identical analog front ends. I'm sure they are. I'm not going to look, but yeah, pretty sure they're absolutely identical there. Now, this actually differs from the analog section used. In fact, I'll try and put them possibly side by side here in the shot, different to the one used inside the other 1000X series. So this is the 1000X-E series, and it looks like they've got a slightly different front end. There's 2 relays in this one. There was 3 in the, I'm going to call it the older one, because this one is brand spanking new. And we've got some trimmers there, which I don't believe that we had. 2 trimmer caps up there that we didn't have on the other one. So yeah, 2 relays. But apart from that, the top section, actually, all this section in here looks pretty close to identical. So the previous one had a 200 megahertz bandwidth. This one is available in a 200 megahertz model. So I'm sure, absolutely sure, that the base model unit, if you bought the 100 megahertz version, it's going to have the 200 megahertz analog front end, and they just software limit it. But if we have a closer look at that identical section that we had before, we've got our Cosmo relay there, a 595 port, digital port expander, of course, and an 8370. Let's check that one out. So to be verified later, but I'm pretty darn sure that everything is identical, including the differential gain output amp and the variable gain amplifier in there. I'm pretty sure that they're all the same that we had in the previous model. So I won't go through details. There's the top half for those who love to take screen captures, but I've got high-res teardown photos down below, but I don't know. I didn't get them under the Tagano microscope, so there you go. Beautiful. Oh, look at that. it's better than a macro photo. It really is. But it's limited to 1920 by 1280. Gosh darn it. And if you want to see the bottom of that, and of course you do, there is the bottom for those playing along at home. And there's not much else. Got a nice big cutout in the ground plane there because they didn't want to upset the apple cart. But that looks all neat and tidy. That's a 200 meg front end. I'm not sure what else I can show you there. That's about all she wrote on the new Siglent SDS1202X-E main motherboard. They've really, there's not much in your modern scopes. Then again, if you look at an old, someone will say it, I'm sure, look at the old Tektronix TDS210, for example, which is like 25 years old now or something, and that had bugger all in it, but it also had bugger all performance as well. But this thing is very remarkable, and it's all thanks to the Xilinx Zinc processor down in there, and nothing else. That's what handles all the grunt in this thing. 1 meg point FFT. I believe it's got hardware serial decoding. It's got a complete digital trigger system, which is effectively zero jitter, they call it, because it's digital and you get just one. Yeah. Anyway, because you can extract it out instead of doing the triggering in analog. Anyway, probably pros and cons both ways there. And it's all integrated inside the Zinc, the FPGA part of the Zinc in there. Whereas the ARM core, of course, would be running all the OS and the display and everything else. So, yeah. Oh, we've got another HL there. There you go. HL1, HL2. They've got to be LEDs. I don't know. I haven't powered this thing up with the back off it yet. It works! Flishy flashy. And you betcha that TXRX is a UART. Ta-da! I'll dump this on the EEVblog forum for those playing along at home who want to check out this. But once again, it uses U-boot just like the 1000X series that we're playing around with last week. And ECC is disabled and NAND 256 megabits. I don't know. Anyway, you can go in here. Let's see if there's anything interesting. Is there ARM Linux kernel? This is not going to be a hacking video by any stretch. We just want to have a quick booting kernel, booting Linux on physical CPU, Linux version 3.19.0 for those playing along at home. GCC version, there you go. It's all happening. It's all happening. So, is there anything interesting? So that's all. The Linux boot stuff, USB, blah, 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 Xilinx data, Xilinx AXI DMA engine successful. That'd be for dumping all the high speed. Oh, Open SPI dev HC595 failed. What? That's to speak to a 595. But it got this one here, did it? Anyway, that's the port expander, I would be guessing, for the that they use on the front ends, but they might have. No, we didn't see a 595 anywhere else on the thing, did we? So I think we're can assume that that's the front end, but there doesn't seem to be anything hugely into a test. I don't know. I'm not going to look into this in detail. The dump's down below for those who want to check it out. Oh no, more stuff down here. Skippy. What else have we got? Driver manage, blah, 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 blah. Error, module. Doesn't sound that great. Anyway, but this may not be a release version. So, yeah, don't take this as gospel. And bingo, we can actually talk to this. I tried help, and help not found, bin ash, whatever that is. I don't know, all the Linux people are probably screaming at me. So I tried help games, of course, because the more complicated these things are, the more they have to help you out, apparently. So, help not found. Hang on, I know what to do. Damn it, they've taken out the password.